For many of us, the first chemical reaction we're exposed to is a classic acid-base reaction between vinegar and baking soda in the science volcano. Today we're going to put a twist on that and we're going to bring it outside in the snow and make it much, much bigger on becoming their science hero. Building a snow volcano requires a decent snowfall, and the snow has to be a consistency that can be well packed, similar to what you would need for making snowballs. Be creative and build a structure together with your little scientists. Then create a crater at the top of your volcano to erupt. Our crater was roughly 5 or 6 inches deep and 4 inches in diameter. Then pack the snow inside the crater as tightly as possible, as we want our solution to collect in the top and not seep into the snow. Now your volcano is ready to erupt. Alright, so the first time we did this experiment, Nathan and I just kind of were winging it outside near the, and we built up a snow volcano, had a lot of fun doing that. And I ran inside and basically just said, let's go grab the vinegar, the dish soap, the food coloring, the water, and the baking soda, and let's just have fun with this. And the first time I did it, it kind of fizzled out and didn't really get as much of a cool result as I had expected. I'm gonna show you why. So this is part of this. I want to show you some of the things that can kind of go wrong. So the first thing that you want to do is you want to mix the baking soda and water. So I'm going to use this vessel right here for mixing everything together. Mix the baking soda and warm water together. So I used half a cup of baking soda and 2 cups of water. Now there's some versions of the experiment that don't say that you even have to use water. You can get away without using it. It helps you get a good mixture going though. Okay. To that half cup mixture, we're going to mix half a cup of dish soap. This is going to create all of our bubbles. And then we're going to add a couple drops of food coloring. And after I mix this together, we brought it outside, and I first poured in this mixture, even though I knew that this was going to go into the volcano and some of it was going to seep into the snow. I just had no idea how much. So what I had done was I poured this, and if this was our volcano, I poured this into the volcano. And this is roughly what I assumed the volume was. It was about 1 liter, just as an estimate. I poured that into the volcano, and then right behind it, Nathan poured in approximately 400 milliliters, or 2 cups of vinegar. And I'm not going to mimic it here because obviously it would make a huge mess. And he came right behind it, and it made a good volcano, but honestly, in my opinion, it wasn't great. So at that point, we went back to the drawing board, and we said, all right, we don't really need to change up what we're doing chemically, but we might need to change up what it is that we're doing in our actual reaction. And that's when you can watch the video, we watch it, and you notice that I go 1, 2, 3, and he comes right behind me and pours the vinegar in right behind it. And we get a much more explosive reaction, and that's because the baking soda and the vinegar get this mixing action going right away. Get to have this nice eruption in something that's much more visually fun. So the experiment is not just about the reaction that's going on, but it's also some of the mixing dynamics that you kind of have to worry about. Because otherwise, if you don't think about some of these things, even though you're reacting a certain amount of baking soda with a certain amount of vinegar, lots of times those two chemicals don't even get close enough to each other to react and actually get the reaction going that you're looking for. All right, so once I realized that baking soda and vinegar were really cheap and that I still had a few days to work on the snow volcano because of our weather, I kind of really started playing around outside on ways to optimize this experiment to really make something fun and exciting for the kids. And one of the things I really settled on was when doing the snow volcano, even though I could dig out the insides and I could try to just erupt it right in the inside, it really made a lot more sense to have a nice vessel like this vase inside for a couple reasons. One, I could obviously didn't have to worry about any of the solution going down into the snow volcano. But two, I also just was able to have a much thicker, wide open bulb bottom where I could hold a lot more liquid while still having a much thinner top here. This thinner top allows when the reaction happens, it to come out much more forcefully. Then I started optimizing basically what could I do, and I realized really what I needed was just as much vinegar and baking soda as I could get in there to react with one another, the better. So we started to play around with that, and what I settled on was actually I could get about 2 cups of baking soda in there. And it might seem like a ton, and it is. Look at all that. That's all baking soda that we're trying to settle on to react in our react together. And I was going to mix that together with 2 cups of water. And what you can see what I'm settling on here is actually filling this vase up pretty high. We want to mix that together again to try to get as much of it to react, or as much of it into solution as possible. When I actually do this, I was actually mixing it in a bowl and then pouring it in afterwards. To that, I upped the dish soap content to a cup. And then used a nice healthy squirt of food coloring. We also settled on red is the most realistic or the most lifelike probably for a lava volcano. You use whatever you want though. And you're going to see later on when we do this that even though I'm showing you with red, and red is probably the most stark contrast, we did it with a lot of different colors. And you can see I can get a nice good solution that I can mix up really good here. Now the key is when we start this reaction, we want to make sure that the baking soda hasn't had really big chance to settle. So we want to stir right up until about we're ready to do the reaction. You can see there it is. Now I upped the amount of baking soda, so as you can imagine, I also increased the amount of vinegar. And what I ended up doing was I ended up filling up one of these buckets. These buckets can hold about a gallon. I would say during the reaction, I probably ended up using about half a gallon per vase. But I had this buried underneath, so you couldn't see the vase, obviously. And I buried this as much as I possibly could. Now, the other reason why you don't want to add the solution until you're really right about to do the reaction is I do the reaction, I mix it all together with warm water, and that's to get as much of the baking soda to dissolve as possible. If you do it with cold water, you get much less baking soda and baking soda to dissolve. And of course, reactions happen typically much faster in warm solution. So then I came right behind it with my vinegar solution, poured it right in. And even as the reaction's going, as this reaction's coming up, I just keep pouring. I just keep trying to get as much of that as I possibly can in there. And as I do it, the reaction keeps going and going and going, and it creates a much more fun visual.
We had so much fun with our traditional volcano in the backyard, I wanted to build something even bigger and better, and came up with this triple volcano in the front yard. I utilized a pretty big pile I had already formed from shoveling the driveway, and then just added a bunch more snow to it, packing it tight to my volcano. I had 3 roughly equal-sized vases, with the one in the middle being a bit higher. and I did my best to control the flow of the eruption in one direction, toward the sidewalk, which is where I would have my spectators observe from. I then built up around each of the vases, so there was a backstop, hopefully pushing the eruption down the front face of the volcano. I also carved paths between each of the vases, hoping to create as forceful of a flow as possible. Let's see how I did. Are you ready?
Hmm?
1, 2, 3.
It's like a water slide. It's like a water slide. Let me touch it.
Wait, give it a second.
But
Well, let it all kind of come out.
it smells disgusting.
Does it smell disgusting?
This one has more. Why does that one have more?
I might have poured a little bit more on that side. I think this bucket was bigger. So that one ended up being bigger in general.
Can I touch it now?
You can touch it, but you're going to have to wash your hands when you get back inside. Okay. Oh, take your gloves off, Mills. You can't touch it with your gloves on.
Oh, it's really cold.
Is it cold?
Yeah. Yeah.
Do you think maybe it's because it went down the snow?
Oh, yeah. Oh, it looks disgusting on my
Is
hand.
it kind of cool into different colors? The chemistry behind the snow volcano is actually quite simple. The three essential components to the reaction were baking soda, vinegar, and the dish soap. When we added all three to our volcano, we got an eruption. Now let's take a deeper look at exactly what is happening here. Baking soda is made of a chemical called sodium bicarbonate, or NaHCO3. We are reacting this with vinegar, which is made of acetic acid, or CH3COOH. These two compounds perform a simple acid-base reaction where the sodium atom of the sodium bicarbonate swaps with the hydrogen atom of the acetic acid. This forms two new compounds, carbonic acid, or H2CO3, and sodium acetate, or CH3COONA. Carbonic acid is not a stable compound, and therefore undergoes a secondary reaction known as a decomposition reaction. In this reaction, it breaks down to carbon dioxide, or CO2, and water, or H2O. Carbon dioxide is a gas, and rapidly is trying to escape our solution, and as it does so, it interacts with the dish soap, forming lots and lots of bubbles. This is what gives the eruption effect in our volcano. So we really enjoy getting to put this spin on the baking soda vinegar reaction. I hope you saw in this video that this reaction can be scaled up or down relatively easily. So have fun with it. You can do this with your little scientists in a small bottle, or make it really big in the snow volcano like we did. So remember to encourage your little scientists to explore and question everything.